Every once in a while, I go back and review things about soldering, see if there's something new that I haven't learned, review old things just to keep myself sharp. Some things change in life. For example, I used to have to wear glasses, now I don't. So I have to be more conscientious about wearing eye protection and things like that. So while I was doing that, I started putting together two different videos, it turns out. One of them is on successful soldering, and the other is on soldering safety. And so this is part one. This is soldering successfully. And yeah, so let's go through this. I suggest that you keep a tally of the questions that you get right, get wrong, so you can go back and review these things. Note that this is a self-test. It's not going to be training. It's not all-encompassing. You do need proper training before soldering is a safe endeavor. What is the purpose of flux and soldering? I get a lot of comments on my soldering videos about flux. So what we're going to do is we're going to ask the question. I'm going to give you a second or two to think about it. You can pause the video and then we'll go on to the answer. Okay, so the answer is flux removes oxides from the metal surface. This includes lead, tin, copper, and it also creates a temporary barrier against more oxidation while the solder is wetting and flowing over the joint. As the heat increases, the organic flux, so it's like rosin, burns off, and inorganic residues, so the salts that are left behind, the borates, these look like a dark brown glassy substance, so that's what's left behind, remain as crystalline or amorphous residues, mostly amorphous. And note that using too much flux is difficult to remove, and it can soak into low quality PCBs. I've had this problem, so too much flux is a bad thing. Next question, why must both component lead and the PCB pad be heated before applying solder? So this is the component lead and this is the pad. So why do you need to heat both of them before you apply solder? Ready? Well, you have to ensure that the solder flows and it heats both surfaces, forming a reliable joint. So also if you heat one and then the other, I've had this problem, you overheat the pad or the component, one or the other. So you don't want to dwell too long on both. If you just try to apply, like this picture, you try to apply heat only to the lead and then get the pad to heat by doing that, there's a very good chance you're going to overheat the component. What is the typical melting point of 6337 tin lead solder? To be honest, I never remember this. But it's important because you need to remember the temperatures are dangerous to skin and they create a situation where things burn. It's about 183 degrees centigrade, 361 Fahrenheit. So it's hot enough to cause fire and serious injury. Why is lead-free solder harder to work with than tin lead solder? And I know this from experience, but I didn't really know the answer. Because it has a higher melting point. Yeah, I should have been able to guess that because, again, I've worked with it. It wets surfaces less easily. Yep, that's also my experience. And it forms more brittle joints. It's easier to get a cold or broken joint like down in here. Yeah, the first two I knew. The third one I haven't done that much with lead-free solder because I just don't like it, but yeah, okay. Something to keep in mind. Number 5. By the way, there's about 20 some questions, so we'll take a break in the middle. What happens if you apply rosin core electrical solder directly to the iron instead of the joint? Well, yeah, what does? Because I've seen a lot of videos on YouTube where people do this. It's a mistake. You initially have to do it to wet the tip of the soldering iron. But yeah, this is not what they're talking about. This is when you're continuing to solder and you continue to put the solder against the soldering iron instead of the joint. Well, the flux burns off without reacting with the workpiece. So yeah, the solder is not going to bond properly because you're just trying to melt basically the raw tin lead mixture onto the surface of the thing. And the flux hasn't had a chance to do the cleaning or removing of the oxide. It takes a lot more solder to do the job, and it creates weaker cold joints. Why should solder joints be shiny and smooth? You ready? It indicates proper wetting and solidification, ensuring mechanical and electrical reliability. Yes, if you have a joint that looks like this, and I haven't removed the flux on this, and this picture is actually from my video. I think I titled it something like "Doing It Wrong but Getting It Right." So you can see that the solder is shiny outside of the fluxed area. I haven't removed the flux. Dull, scrunchy, wrinkled, dark solder can be a sign of a cold joint, and if you have that, you want to reflow it. Number 7, how can you tell if you've applied too much solder? Yeah, okay. For somebody who has a lot of experience, that's kind of a funny question, but you do see a lot of it again on videos. The answer is the joint forms a large blob or ball like this. So this is your lead and this is your pad, and it just it's just a big lump. You need to wipe it off with a soldering iron tip or remove it with solder wick and redo the joint. Okay, on the other side of the coin, how can you tell if you've applied too little solder? So this is actually a diagram of a well-done one. So how can you tell when it's too little solder? You'll have gaps. You'll be able to see the hole in the pad, or you'll have something that looks like this, and this side of the component will not have any solder on it. Something like that. Number 9, what is the best shape of a through-hole solder joint? Okay, we've already kind of given a hint on this. It should be a concave fillet, and it should look like this all the way around. And even on the other side, you should see a little bit coming through. The wetting angle is 40 to 70 degrees from horizontal, and you should have a smooth, shiny, concave surface like that. So this is a beautiful diagram. It looks like a classic volcano shape. That's how I've always described it. Why is tip cleanliness important? So here's the opposite of that down here. So why is tip cleanliness important? Well, the oxides and residue will prevent an efficient and high surface area solder bridge. So when you first start a solder connection, you apply a little bit of solder to the soldering iron tip, and it forms a bridge to the workpiece. And if the tip is dirty or nasty, the solder won't want to stay in contact with the soldering iron tip, and you just won't get good heat transfer and proper solder flow. So that's the reason. What is the proper method to clean a soldering iron tip? Boy, this is almost a religious belief, but yes, what is it? You can either use a damp sponge like this or brass wool. Both work very well. I have changed from the sponge to the wool lately because the wool is faster and it doesn't cool off the soldering iron tip. Number 12, what does a cold joint look like? I get a lot of comments underneath my soldering videos about cold joints, and it's very clear that most people don't really know what one is. Okay, you ready? Let's take a look. It looks like this. This is an excellent picture of one. You can see there's a gap around here. There's kind of a lump here. The metal doesn't look, I don't know, it doesn't look right. I mean, it kind of looks a little bit dark, but you can see that there's no connection. That the pad has been wetted very nicely, but there's none of the volcano shape between the pin and the pad. So you'll get a dull, grainy, or cracked, and often with no wetting or blob-like appearance. So people oftentimes try to force solder onto the pad and kind of just lump it on there until it looks like a joint. But yeah, it's underneath, it's going to look like this. Number 13, what is meant by tinning a wire and why do it? So here's somebody tinning a wire. I'll let you decide whether that's the correct form or not. So what does it mean? Well, a tinned wire has a coating of solder on it, and or other easily wettable material. Sometimes very high quality wire will come silver plated, and silver is very easy to solder. It helps make soldering faster, which can prevent overheating, which is a good thing. Yes. A lot of times when I have a pad that's really dodgy or it's starting to lift, pre-tinning the wire, pre-tinning the lead, making sure everything's clean and pre-tinned will help prevent that any more damage from happening. And it often forms a better quality joint since the new solder will wet better with a tinned surface. And it also, like here, it will make a multi-strand wire into a single one, which can make joining it somewhere much easier. Okay, it's break time. We're halfway along. Pause the video, take a moment, get your favorite beverage, and when you're ready, we'll resume. Okay, back again. Number 14, why is preheating sometimes used in soldering? I don't do this very often, but yes, sometimes I am forced to do it. The answer is it reduces thermal shock to components and improves solder flow, especially with larger components. If you're soldering things with very large leads or other connection points, yeah, you may have to preheat it to make it work right. 15, why is ESD, electrostatic discharge control, important when soldering certain components? So here's a wrist strap for grounding. So yeah, why is it important? Well, sensitive components, especially things like moss and CMOS, can be permanently damaged. They're very susceptible to undetectable static discharge. You won't even see it, you won't hear it, you won't feel it, but your circuit will not work. And this has happened to me. I was so confident that I had done it that I just pulled the chip out of the socket, put in a new chip, and it worked fine. But yes, I had accidentally shocked the component. So it can happen without you even knowing it. What is solder wick? Desoldering braid's another term for it, and how does it work? So yes, I've used a lot of this stuff, especially when recycling components. And the answer to 16, it uses capillary action to draw the solder, to move the solder out of a joint and into the wick. So yeah, it's just like a candle wick or like wicking something up with water, only with molten lead and tin, it just goes right up into that braid. Why should you avoid prolonged heating of PCB solder pads? And I'm chuckling because this circuit board right here was, wow, it was my nemesis. I had a lot of problems with it. It can lift pads from the PCB or damage the laminate. Yes, this was a very inexpensive kit from a certain company whose initials I won't mention. And boy, just getting this soldered, these things just love to curl right up off of there. So yeah, you want to make sure everything's clean, ready to go, and that way you'll spend a lot less dwell time with the soldering iron in contact with everything and get away with a good joint without lifting the pads. Why should components be mechanically secured before soldering? So like twisting wires or like this, or bending wires into through holes or whatever it is. Why should they be mechanically secured before soldering? There are really two parts to this answer. And the first one is that if you move the component while the solder is cooling and solidifying, you can get a cold joint. Yeah, you'll get the component to release from the solder, or you may get this nasty wrinkled appearance where you get the oxide of the solder, and it's actually the only thing making the connection, so you get a high resistance joint. The second answer is solder only joints under pressure, tension, or vibration can move or separate. Okay, let's do a few true-false questions. First, when soldering wire joints, you should apply heat from under the joint and add solder from above. True or false? I have seen numerous videos, popular videos, saying that you must heat from underneath. And the only thing I can guess is this comes from holding over of people using torches to solder pipes, because that's the only case I can really think of where you have to do that. The answer is false. Yeah, soldering from below is slower. It's unnecessarily wick solder out of the joint. You waste solder, you create more solder waste, and it creates burn hazards for hands. I'll put in the description a video link to my video which debunks this. It shows the time, it shows the solder waste, everything that happens from soldering from underneath. To properly solder wires or components using typical electronic roll solder, you need to flux joints before applying the heat and solder. Is this true or false? Okay, another thing I get a lot of comments on, and the answer is false. Electronic solder typically contains resin in it. It has a flux core, and if the joints are properly prepared, you do not need to add more flux. In fact, all it does is slow you down before and while you're soldering, and then after you're soldering, well, you got to go in and you need to clean it up. So, and as you brush or rework the soldered surface, you have more opportunity for circuit damage. So yes, this is false. What two things are required to make a mechanically and electrically sound solder joint? Clean the soldering iron tip, added flux, adequate heat, lead-free solder, or clean the workpieces. Now, we've already talked about some of these, okay? What's the answer? Well, a clean soldering iron tip, it doesn't hurt, yeah, but it is not absolutely not required. Added flux, well, we already talked about that. So if you need to add flux, it's a sign that the parts are not clean. It can be an oily joint where just like finger oils have contaminated the surface. It may look shiny, but you know, you've touched it with fingers. Too much flux becomes a removal headache. Adequate heat is the first required thing. I'll put a link in the description below on my video on that. Lead-free solder, well, yeah, we just talked about this. And clean workpieces. If you do these two things, you can do a lot of things wrong and you will still have a viable solder joint. So what are the minimum requirements for safe soldering? High protection, fume control, approved lead waste disposal, non-combustible surroundings and fire extinguisher, and training. And are we ready for the answer? All the above. Shouldn't be a surprise. Number 23, for electronic and wire soldering, rosin flux is typical. Acid flux is for stubborn connections. True or false? Okay, are we ready? False. Yes, I had learned this the hard way. Do not use acid flux on wire or electronics. You will regret it. It not only corrodes the components immediately during the soldering process, it wicks into small spaces like the fine little pieces in between the wiring, the little spaces in between the wires. And it gets underneath chips and it soaks into circuit boards and it will continue to eat at metal for years. I had a kit I had for 20 years. Every year I would take it out, have to clean the flux out of it. Finally, it just ate all the internal components away. I mean, it ate the legs off of the chips and everything. It was just, yeah, it was impossible to remove. So use rosin non-acidic flux in electronic soldering. Is lead-free or lead solder best and why? Okay, so this is just kind of a free-form question. Consider the health risks, the strength, the fumes, the tin whisker failure, waste disposal, etc. There's a lot of things to consider between these two. You may want to pause here if you have a big answer, but yeah. Okay, ready? Yeah, so you should give yourself credit if you considered things like lead-free solder is environmentally better, it's regulatorily compliant, and it's okay for consumer grade work. Notice the consumer grade work. Lead-based solder, its reliability is superior, it is more ductile, it moves better before it breaks, cracks. For safety critical performance, it's better because it won't give out, especially if there's vibration or other environmental issues. But it is more toxic, it requires more careful use and disposal efforts. So what is a cold joint and how are they caused? Okay, we've already kind of given this one away, but again, this is one of those things that pop up in the comments section, and it's very clear that a lot of people are confused about them, don't know what they are. So I thought I'd spend a little extra time on them. Okay, ready? A cold joint has solidified without full bonding, yes, between the work pieces. It is usually caused by insufficient heating of both the joint of the work pieces and the solder or contaminated surface, oil, oxides, and so on, as been mentioned before. The joint is mechanically weak and electrically high resistant and unreliable. So yes, it can be weak, it can be electrically high resistant, it can be unreliable, or it can be any combination of the three. They appear dull, grainy, rough, or uneven surfaces versus shiny and smooth. Sometimes it looks like a blob just sitting on a pad rather than flowing into it. And if you're lucky, it'll look really bad like this one where you can actually see the cracks around it. Well, we've reached the end of Soldering Successfully, your self-test. This is part one of 2 parts. And the second part is the soldering safety self-test. I hope you'll go over and watch that next. In any event, I hope you find this useful and interesting in your future soldering projects.